Today we're going to factor some tricky trinomials, and they're called tricky trinomials because the number in front of the x squared is going to be something other than a 1. So previous day with factoring of regular trinomials, they all had 1's in front of the x squared, but for today we're going to have numbers that are not going to be 1, and that's going to be your clue really to make sure that you factor using the technique that we're going to look at for today. First, we're going to expand. Okay, we're going to take a couple of brackets here, multiply them out, and get a trinomial, and then look for clues to help us go backwards to get the factoring that we need for today. So if I multiply these out, first times first for 6x squared, outsides, 8x, insides, 9x, and lasts 12. So that leaves us with the trinomial 6x squared plus 17x plus 12. And again, for the second bracket, a set of brackets here, we've got 8x squared minus 4x minus 6x minus 3 and 8x squared minus 10x minus 3. Okay, so the goal is to start with something that looks like this and end up with an answer by factoring with a couple of brackets like this. Now you can see we've got the number in front of the x squared here that's not a 1, so we're going to have to figure out how to factor that properly, and just by looking at the expansion, where did this 8 come from? It came from the first 4 multiplied by the first 2, so multiply these two numbers together to get the 8, and the same over here, multiply 2 times 3 to get the 6. So not only now are we going to have to consider factors that multiply to 12, but we're also now going to have to think about numbers that multiply to 6. And the same over here. Multiply the firsts together to get the 8 in front, and the lasts together to get the 3 at the end. So we're going to have to think about numbers that multiply to 8, and also numbers that multiply to 3. And hopefully all of those factors, if you can keep them straight, when we add or subtract them, are going to give us that number in the middle, the negative 10 here and the positive 17 over here. So how do we keep all of those numbers in our head? Well, you could try to keep them in your head organized somehow. I'm not sure how, but we could also make a chart to help us with that. And I think that's what we're going to do. We're going to make a chart to help us keep track of all of those numbers. All right. So here's what the questions are going to look like. We've got 3x squared plus 17x plus 10, and we're going to make a chart thinking about now numbers that multiply to 10, and we're also going to have to think about numbers that multiply to 3. So to keep those factors organized, I'm going to write a chart. The numbers that multiply to 3, 3 and 1. Numbers that multiply to 10, 2 and 5. And you can also write down 1 and 10 if you would like. And once we've done that, we will need to take one side of the chart and flip it over. So this side has fewer numbers on it, so I'm going to flip that side over. I'll write that as 1 and 3. Now the reason for that is we need to be able to get all combinations of the factors together when we multiply them, so we can come up with this sum of 17 in the middle. So one side of the chart gets flipped over, the other side you can leave as it is. More than likely there's one side that has fewer factors, so you probably would choose that side to flip over. Okay, here's what we're going to do. We're going to kind of cross multiply to come up with that sum of 17 in the middle here. So if I'm looking at the first set of factors, my first multiplication will be 3 times 5 for 15, and 1 times 2 for 2. And you have to think in your head now, can you take 15 and 2, either add or subtract them, and get 17? Well, yes, of course you can. So what I can do now is write out the brackets exactly the way you see them in the chart. My first bracket should look like this with 3 and 2 in it, and my second bracket should look like the second line with 1 and 5 in it. So if I just copy that down, 3x and 2, 1x, and you can write the 1 or not, 1x and 5. You'll notice that I put the x's in here automatically. The only way to get the x squared at the beginning here is going to be by multiplying x times x. So 3x and 1x at the beginning, and 2 and 5 at the end, exactly the way they're written in the chart here. And the signs you'll have to figure out for yourself, like you did with the trinomials. So if I could look at the outside multiplication, that's 15x, and the inside multiplication is 2x. So to get 17 in the middle here, I need positive 15 and positive 2. So 15x plus 2x is 17x, and then 2 times 5 is 10. And of course the firsts as well, 3x times 1x is 3x squared. So it all works out. Chart here, I think, definitely your best option in terms of trying to keep all of these factors straight. Next example, same thing. You can notice that the number in front of the x squared is not a 1, so you can make a chart to help you organize all the factors. If I just write them out briefly here, I've got 1 and 2 for the factors of 2. And on the other side, factors of 5, I can write 1 and 5. And one side of the chart has to get flipped over. In this case, it doesn't matter, so I'll just flip this side over, 5 and 1. Okay, and again, we just start sort of cross multiplying and try and come up with numbers that either add or subtract to get 7 in the middle here. So my first attempt, 5 and 2. If I take 5 and add 2, I'm going to get 7. So again, first attempt worked. Brackets are exactly the way they're written in the chart here. My first bracket should be 1x and 1, or just x and 1. And the second bracket should be 2x and 5. And the signs you'll have to figure out for yourself. So first, x times 2x for 2x squared. The outside, 5x, and the inside, 2x. So it should be 5x plus 2x is 7x, and then 1 times 5 is 5. Next example, a little more complicated, a few more factors to deal with there. So we've got a chart we can make with factors of 6. So we've got 2 and 3. You can put 1 and 6 in there if you'd like. And we've got 2 and 5, and 1 and 10. And we'll have to take one side of the chart and flip it over. So we've got, I'll flip the side over. I've got 5 and 2, and 10 and 1. So a little bigger chart this time, more factors to consider, but we still work through it exactly the same way. You'll have to come up with some cross multiplication here that gives you the sum of negative 11 in the middle. So first attempt, 10 and 6. 10 and 6, can I add or subtract 10 and 6 and get 11? That's not going to work, so we'll have to come up with something else. How about 20 and 3? I don't think that's going to work either, so we'll try another one. How about 4 and 15? 4 and 15, I could add or subtract and get 11, as long as I have negative 15 and positive 4. So that pair is going to work. Again, the brackets are written exactly the way they are in the chart. So if I could just put a bracket around here, and a bracket around here, and here, and here, and write them out exactly the way you see them. So 2x and 5, and 3x and 2. And signs you can figure out for yourself. We've got 4x on the outside, 15x on the inside, so that should be positive 4x, minus 15x is negative 11x in the middle, and minus 5 times positive 2 is negative 10, and we're done. You can see as the charts get bigger here, it gets a little more complicated, but as long as you can keep the factors straight, and even some of these factors you might want to not even write down. So 1 and 10, probably not a good choice in terms of, or probably not a high probability of using that as a factor, but don't forget about it. Sometimes people forget to write down the 1 times the number, and that is actually the one that you need. So to be safe, I guess you could write them all down, but with enough practice, I think you'll find that some of the more common factors you can write down, and some of the more uncommon factors you just leave out. Okay, last one here. Well, the number's a little bit bigger than the other examples. I've got 20 and 66 and 14, so lots of numbers to write down, lots of factors to write down in our chart, which you could do directly if you'd like, but if you'll notice, these numbers are all divisible by 2. And what we could do then is factor out or common factor first, make these numbers a little bit smaller, and then deal with our chart afterwards. Okay, so a little bit tricky here, but I think the first thing we can do is some common factoring. And that's going to help reduce the size of our numbers and make our chart a little bit easier to deal with. So if I do that, bring out a factor of 2 here, 10x squared plus 33x minus 7. There. All right, a little bit easier to deal with. Still a number here that is not a 1, so we're going to have to use the chart to help us organize our numbers. And if I do that, I'll just use the space over here. Numbers that multiply to 10, I'm going to write down 2 and 5. And I won't write down the 1 and 10. I'm hoping that 2 and 5 will work for me. And on the other side, for 7, I've got 1 and 7. And I will flip that over. So one of these I'll flip over. I'll go 7 and 1 on this side over here. And check our multiplication. I've got 14 and 5, and that's not going to work to get 33, that's for sure. How about the second one? I'll go 2 and 35. 2 and 35. So yeah, I can definitely get 33 from that if I take positive 35 and subtract 2. So the brackets then are going to be, now I'll copy the 2 here, right? That's already been factored, so we just leave that where it is. First bracket, 2x and 7, and the second bracket, 5x and 1. Okay, and the signs, like I said, we need negative 2x and positive 35. So 10x squared minus 2x plus 35x, negative 2 plus 35 for 33, and then 7 times negative 1 is negative 7. And that's it.